And so you're recording, we're good to go?
Yes.
All right, so I'll just forego the introduction because I already did that and use a couple minutes here just to mention, first of all, this is a recorded little presentation, so I'll save the questions for the end. And no matter which tool you use, I encourage you to use a tool, one of these 5 that are presented today. The AIA 2030 commitment report shows that at least starting to do analysis shows, improved results in terms of energy use. So I look forward to watching the other presentations today as well, once the recordings are available. One of the first things that people ask when you talk about energy modeling, and rightly so, is it accurate? So the next couple of slides are going to talk about validation. Insight, which on the back end uses Green Building Studio, uses DOE 2.2 as its energy modeling engine. It also can use Energy Plus, and its current new feature in 2020 and 2021 analytical systems uses Energy Plus, and I understand it'll all just use Energy Plus in the future. It's been validated against the ASHRAE 140 standard, which is mentioned in ASHRAE 90.1 Appendix G. That standard is, or the results from that ASHRAE 140 validation are published online per the requirements of that standard. And then Autodesk also runs its own climate server, which has TMY2 data for 2,000 physical weather stations and 1.6 million virtual weather stations, as well as historical weather data. There's a blog post there you can read more about. You can grab that out of the recording later. Autodesk is a research partner with GBXML, so greenbuildingxml.org, and they helped together develop the level 3 compliance, which gets at more accurate geometry and an automated energy analysis model. So for that latter idea of an automated energy analysis model, you would take your design platform model and without any manual intervention create the EAM. And that's what's showing across the top there is you have a Revit model. You can see a section where there's a slope floor and a roof overhang and a floor overhang, which are just extensions of that single Revit element. And the result is the roof canopy and the floor balcony become shade surfaces. In the lower left, you can see, let's say this is a tilt-up precast wall that goes from the top of footing to the top of parapet. The result is going to be 3 separate elements: a below-grade wall, an exterior wall, and a shade surface. And again, like I said earlier, I encourage you to use all tools. This is just an example of Sapphira has special modeling requirements where you'd have to split that to get it to not to count the whole area of the wall as an exterior wall. And then the second part of that standard is the accuracy of the model. Comparing a Revit model to the energy analysis model, we see the results are very similar or super close, much more accurate than traditional energy modeling of days gone by. Every Insight run has a ASHRAE 90.1 baseline, and here's an example from a blog post I wrote. The same model, occupancy type set to warehouse, healthcare, office, and you can see the automatic ASHRAE 90.1 default. Of course, the healthcare project consumes more energy for the same size building. The EUI mean is also listed there, which we'll talk more about, that idea of an average or a mean. Another important aspect of energy modeling is thermal zoning, and Revit's energy analysis model has the ability to include perimeter and core thermal zoning, which is also mentioned in ASHRAE 90.1 Appendix G. There's a blog post, pretty detailed, that I wrote that you can see there, and an example of when you don't include perimeter zoning, and when you do, the model on the right shows, and I'm just going to back that up for 1 second. The model on the right shows perimeter zoning for each orientation of the building. So big picture, you have the entire idea here is that it's a paradigm shift in how energy modeling has traditionally been done. I like to say we used to put the cart before the horse, in that we would enter a bunch of inputs and hope to get the EUI that we want. Now we have a Revit model, and all we for sure need is our location on Earth. We push the Revit model out to Insight, and then all of the inputs have a range. So a roof might be R0 all the way up to R60, and we can adjust the bottom and the upper range. And until we have one input selected, we're given a mean or the average EUI. For the sample project I'm going to show you, we're going to be in Climate Zone 7, Duluth, Minnesota, which is on Lake Superior, which is actually where I used to live 2 weeks ago. Now I live in Texas. The project happens to be on a site with some elevation and the world's largest body of water. As you can see here, it's the same size as Ireland, that one lake. So we're going to take we're going to basically open an empty Revit project and work through the process of creating a mass, pushing it out to Insight, and looking at the inputs. I like to just show this example. It's a sped up video of the entire process, just to give you a really good idea of the entire process, and not wonder, you know, what if something was done in preparation for this presentation. So we're using Revit's massing tool, and with this simple mass, you'll see we'll be able to get some very accurate results and even some microclimate data. So we just extruded this very simple mass. We're going to go to an elevation, and we want to make sure our levels in Revit correspond to the number of stories we desire in the building. So we're going to create a third level. This template started with 2 levels. And although this last level isn't required, we're going to add one more for the roof element. The top of the mass is aligned with the roof. And then we're going to do something that's very important, in that we're going to select the level, and we're going to associate mass floors. These options correspond to the levels we just created, and the result is an analytical floor plate. The next step, so we have our model now, which is a simple mass element. We're going to specify our location on Earth. And you'll notice there's several weather stations there that you could select from, but the closest one is selected by default. All we need is the mass in this case and our location on Earth. And we're ready to push this model out to the cloud. You'll notice if we select one of those analytical floor plates, the floor area is showing up. We could actually do a Revit schedule right now to get the total gross area for our building. Revit or Insight emails us when it receives the model and it's processing it. When we click on the icon there to open up Insight in the cloud, we can begin to create a project. Even though the run hasn't finished completing yet, I was able to click to create a new project in an Insight, give it a name and an image. And the image might be particularly helpful if you end up sharing this project with somebody else on the team who doesn't even need to have Revit, by the way. We'll talk more about that later. And you receive an email when the run is complete. Initially, the projects are in metric. So we're seeing the cost per square meter and the kBTU per square meter per year. So I switched it to imperial, and now we're seeing the cost per square foot and the kBTU per square foot per year. One of the first things we can check is the microclimate data, so the heating loads. If you're familiar with the Edmund Fitzgerald that sank in Lake Superior, you might be familiar with the gales of November. And so now that we have this run out in the cloud, we can look at the widgets, which are each individual range of inputs. If the chart is flat, like the graph is flat, as compared to this graph being rather steep, there's less opportunity for energy optimization. So a steep graph means that there's an opportunity to save energy. We can sort the widgets by importance, so those steeper graphs are listed first. Those are going to be things like operating schedule, and we can adjust both the lower end and the upper end. We might start by adjusting the lower end of all the inputs to comply with the local minimum energy code. And when the dial at the top is red, it means we're below ASHRAE 190. Once it's orange, it's meeting ASHRAE 190. And then at such time it turns green, it means we're aligning with Architecture 2030. So I'm talking about that large circle that's showing the EUI or the cost change in real time. Once we get all those lower end ranges set, we can save a scenario if we want. I'm going to call this the Minnesota code minimum. That way we can get back to that baseline setting. So that's the whole scenario. Some other things that we can do is adjacent shade surfaces, whether it's vegetation or building. We create a mass and don't assign mass floors to it. That automatically becomes a shade surface. Also, as I mentioned, you have several weather station options, and here's an example of two weather stations that are the same distance apart with very different heating design temperature values. So we need to make sure if there's a large body of water or elevation difference, we pick the correct option. It's interesting that we can use a combination of a mass and Revit elements. In the upper right, we have a mass with curtain wall elements to be explicit about our window layout, which results in the energy analysis model in the lower right having a very specific window to wall ratio. This one we're going to look at for just a little bit longer. So the inputs don't matter until they matter. So we can just adjust the widgets in Insight. But once we start to know what they are, we have a hierarchy here of how we can input that. And all three of these dialog boxes are found in the energy settings dialog. By default, just anything that's a wall, no matter what wall type it is in Revit, gets the conceptual types option. And then you can override it, and then you can go to the more detailed thermal properties associated with the Revit material. We also, with that idea of combining, we could take an entire Revit model, which could be modeled in and of itself, but then juxtapose a future edition mass element where that coincident exterior wall now automatically becomes an interior wall when the energy analysis model is created, which is pretty cool. At such time where you've developed the model or the EUI to its extent, you can export that to the AIA document data exchange and then open that project in that system and make additional adjustments. You can also share that project with anybody, and that way somebody who just has internet in the browser can adjust the widgets and develop a predictive EUI, which is pretty awesome. The entire workflow is scalable. This gets really complicated, but if you start to use in a detailed Revit model spaces and HVAC zones, you can set heating and cooling set points and even power for specific electric loads. However, based on the occupant type in a multi-story building, you're automatically going to have an elevator load showing up in your design, but you can account for other loads. On the right here, you can see only these categories are considered as part of the analysis. So generic model and structural columns aren't considered, so that can create some issues. There's no way to crop a model if you're just doing a small addition that has its own heating and cooling systems. And then there's no support for Revit's secondary design options. You'd have to make it a primary design option for Insight to see it. And the last item on that previous slide is it doesn't replace something like train trace. This is meant early energy analysis for architects. But we can export the insight data to raw Energy Plus, DO2, or GBXML format to be imported into train trace or even Energy Plus itself. I would recommend that you create a list of all the inputs like I've done here for the previous firm that I worked at, and work with your mechanical, electrical, and building performance specialists to come up with some guidance for architects who might not be familiar with air infiltration settings and different climate zones and different occupancy types. So having a sort of cheat sheet to guide that would be super helpful. And this is actually in the handout that'll be available. I haven't mentioned that there's a handout, but you can download a handout for this presentation. Some resources. I asked Bunny about this before I listed something that I would benefit from, but I created a course that you can participate in on Michael Kelly's Arc Smarter website. I also have lots of blog posts you can look at for free on my blog about insight, testing various things like how to do an insulated wall with studs that are thermal bypass. You know, in Revit, you can only specify one thermal property for that 3.5-inch space. So you have to do a weighted value, 10% studs and the rest thermal insulation. So there are ways of doing that, and I go through some of those more complicated things. Autodesk has a user forum, so there's a great resource there. Their blog is quite dated, but you can still see some good information on spatial daylight autonomy, solar analysis using their PV tool. And again, there's the dials. Red is bad, orange is ASHRAE 90.1. There's a typo. I don't know what 60.1 is. Architecture 2030 and net zero, those are both green. Green is good. So that was really long-winded, fast 20 minutes. Are there some questions? How much time do we have? 2 minutes left, Bunny?
Yeah, and I'm not seeing any questions in the chat yet, but if you have one, feel free to unmute yourself and ask away.
I have a couple, if you can hear me.
Yes.
Hey, I'm Ron, GSPS Architects in Salt Lake City, Utah. We tried implementing Insight 360 into our projects for about a year or so. Eventually, kind of moved to Cove Tool. If you have the problems we had, that I would like to know if you had any. Well, we have 57 seconds. So,
yeah, there are challenges, and it really comes down to how the model is created. If people are using the floor tool to model countertops, and there's big gaps in the project, that can definitely be a problem.
Yeah, how do you identify those gaps? Is it really an easy way?
Yeah, it's a systematic approach of a section box, stepping through the building 10 feet at a time. Sometimes just looking at the energy analysis model 3D view, narrowing down the analytical surfaces in that view so that you're just looking at the rooms or the windows or the exterior walls, for example.
I see. I guess I'll try to connect with you through email if you have.
Yeah, or LinkedIn. You can see my LinkedIn info there.
That would be great. Thank you. I appreciate it.
That was a very nice introduction, Kieran.
Thank you.